Good afternoon, everyone. My name is Sylwia Styczyńska, and together with my colleagues present here, we represent Glinik Drilling Tools company. Today, I'm going to present you some information about our new outbreaking technology, LaserC technology. It's laser metal deposition technology which can resist exceptional wear resistance coating which can be applied in manufacturing and repair processes. Glinik company is on the market from 140 years, even more than 140 years. Everything started in 1883 when Canadian and Austrian businessmen opened the oil refinery and also tool workshop shop. This refinery soon became the one of the most prospective one in the area, and this tool workshop shop became the equipment, the factory of tools. And in 1899, they produced first drilling tool. After some time, because wars, in 1960s, they started serial production of drilling tools. From this time, they start to produce more and more different tools. And after some time, in 2011, they integrated with TDJ Group. And from this time, the new company strategy, the new image of company, push their products and they enter to international markets. The last recent milestone was in 2021, the first PDC product line was produced. Glinik company employs more than 230 workers, including more than 26 design engineers. They produce more than 3,500 bits per year, using for this more than 1,000 customized designs. More than 90% products are exported. They send these products for more than 50 countries in whole world. Also, Glinik company cooperates actively with more than 100 companies. The core products are PDC bits, drill bits, hole openers, and G-Ramer. One of the most important issues during producing of these tools is the protection of diameter of tools, but also cutting structure of these tools. And here on these graphs, on gray color, you can see which parts of these products has to be strengthened. So, respectively for drill bits, you can see that especially we have to protect the tips of the bits, but also the back of leg body. And for PDC bits, these blades marked by gray color here on this graph. So here, it's really important to implement some new technology to first find some new material which can provide us better mechanical properties, and these neurological parts will be protected even more. And also, the second important thing here is to automatize this process. And because of that, we can reduce the producing time, we can reduce the cost, and achieve better drilling properties. So, Glinik company actively carry out and try to realize the new research to find the new solution for these problems. And because of that, together with National Center for Research and Development and some universities from Poland, like Warsaw University of Technology or Silesian University of Technology, they applied the project entitled Developmental and Verification in Real Conditions of a New Technology for the Production of Large Diameter Multi-Core Bits and PDC type bits with the use of additive manufacturing methods implemented in the laser metal deposition technology. The main aim of this project was development and verification, the possibility of use this laser metal deposition technology in processing in manufacturing of roller cone bit and PDC bits. The expected results were the reduction of production time, reduction the waste during the production, mainly waste of metallic powder using during production, to increase repeatability and durability of our tools, increasing, of course, mechanical properties of these overlays, increasing the efficiency of cleaning cuttings during operating, and, of course, reduce the price. But what is the laser metal deposition? I'm pretty sure that it was explained more and more with more detail on some other stages, but just briefly, we can sum up that this laser metal deposition technology is additive manufacturing technology when the laser beam is focused on the surface of the metal object. There is melting pool in which, in this area, the powder of metal is injected, and this powder can be melted and solidify rapidly. So maybe now let's watch some short video about our LaserC technology from Glinik company. There is no sound here, I think, but it's not relevant in this video. So let's look. The advantages of this process, I will talk more during this presentation later, but now I want to tell a few words about some achievements, because based on the results of this project, our trademark was registered on May this year in the European Union, so LaserC trademark. But also, we are working on registration, during the registration, this trademark also in USA and Saudi Arabia. 3 patents application were also been pending. And now, let's take a closer look to the results of this project and advantages of LaserC technology. So, first of all, LaserC technology provides high density of energy. And because of that, it is possible to melt and solidify this injected metal powder very rapidly. So this resulting in fine grind microstructure, uniform distribution of these particles, and what is more important, these particles are not degraded. When you compare these 2 overlays created by standard method, so gas welding, and LaserC method, so first you can see that this reinforcement phase is distributed evenly throughout whole this cross-section of overlays. And what is more important, look here, that around these particles, you can observe a lot of small other particles, which in this case are different carbides, which combine by combination the chemicals from these reinforcement particles and the matrix. But here, using this LaserC technology, these particles are whole here, so they are not degraded. So our mechanical properties of these overlays can be much higher compared to this standard overlay. The next advantage is low heat input of this technology. So it is possible to surfacing the elements with narrow cross sections. There is also a small contribution of the substrate element, substrate material, so the combination of materials from the substrate and overlays is less, and also the heat affected zone is minimized. So here you can compare the quality of the overlays on this complicated geometry of roller cone bite with standard method, so gas welding. And also, if you want to look closer, so here you can even touch it or look how it looks. So if you want, so maybe after presentation you can look closely how it looks. And what is also important here, so to overlay this complicated geometry is possible not only because we have low heat input, but also our special construction of industrial robot and some other machinery next to this. So, because of these two really important features, like high density of laser energy and low heat input, these effects on microstructure, as I mentioned before, we have fine-grained microstructure, uniform distribution of reinforcing particles, there is limited mixing of substrate with and layer materials, and the heat-affected zone is minimized. And these microstructure features effects on mechanical properties. So the two most important mechanical properties are abrasive wear resistance and impact resistance. And here, when you compare it, you can see that it's at least 2 times higher, these mechanical properties, when we compare LaserC technology and gas welding, means standard technology. The next advantage is high surfacing speed. LaserC technology provides 2 to 6 times higher surfacing speed compared to gas welding, and it makes this technology ideal for large-scale production. I mentioned before about the high quality of these overlays, but there is also some next advantage from this. That means when we have our overlays with high quality, so our process is repeatable, and it reduces the need of use post-weld treatment, so it also leads to reduction of rejects and reworks, so that means that this process is cheaper. And the next one is automation of this process. And it is really important to highlight here that we are the first company in oil and gas industry which automatized this process, so mean overlays or surfacing these working surfaces of roller cone and PDC bits. So this precise application of thin coatings in this LaserC technology and led us to a possibility of apply the thin layers and multiple layers with wide variety of materials. So then we can create our overlays which can be constructed from different materials. So for example, here we can achieve the gradient of chemical materials inside, and also these mechanical properties because of the microstructure. So these key advantages of LaserC technology, enhancing the efficiency, productivity, and quality of our products. this technology was successfully implemented for hard-facing roller cone drilling tools, roller cone bits and PDC bits, so together drilling tools. And as I mentioned before, with really higher and improved abrasion resistance and impact resistance. And the test sets which were carried out onshore and offshore with some other companies exceeded our greatest expectations. And for example, here on this right photographs, you can see the roller cone bit after drilling more than 1,300 meters, that this overlays here is whole. There are not scratches. It's not degraded. So that means that our project was successful. What's more, we want to also apply the results of this project not only to oil and gas industry, but also to some other industries like energy geothermal industry, mining industry, horizontal directional drilling, and water well industry. And to prove that, here I can show you a rotary tangential knife for mining combine with the overlays created using this LaserC technology. Thank you for your attention. If you have any questions, so don't hesitate to ask them.
Very much. So is the range of materials with LaserC the same as with another DMD process?
So here we use, of course, metal powders to create these overlays. And this we can use a lot of different materials. Of course, I cannot tell you exact material which we use here because it's company secret. What is the advantage of this technology, this LaserC technology, is that we can change these materials. So when we want to create some overlays for some other tools to some other industries, so we can easily change it and modify it.
And how often do you use multi-material printing?
What kind of printing?
Multi-material, so you
very often.
Okay, good.
Yeah.
So you can find out more, take down the details there. Is there anywhere on site that we can find out more? Anywhere at the show?
Once again.
And is there anywhere on the show floor here at Formnext that people can come to find out more information?
I'm not sure. Maybe my colleagues know, but probably we can find someone here,
Okay.
of course.
So grab them here while you can. Thank you very much for the presentation.
Thank you.